time no see. I have been a little bit busy with that with that with the preparation for that. So let's get back to our video series, right? Now, in case you have forgot, um, the video series is mainly about showing the progress of how stuff is moving, the process of creating a project, an object to be exact. So it is not something that is clean quickly and can be used as a tutorial most of the time. It's gonna be messy, and that is the whole point of this, to show people that learning new stuff takes time and it will be messy a lot of the time. So it will not be clean, be quickly clear or concise like any video, but we will do our best to complete it. So let me give you a bit of a rundown. What is that? This week to do list. Okay. Now, this should be done. Model the hub, model the cable holder for the Thunderbolt hub, model the box of my USB splitter, model cigarette box, get rid of the boxes, buy another Wi-Fi smartwatch, install capacitor, thermal paste, design lamp holder. Okay. I have let let's give you a bit of a overview of what we're doing. It's a good practice, right? To give myself an overview about what I'm doing. So let's go for lamp. The main problem, yeah, you might have heard about the controversy of bamboo printer, and to be frank about it, I'm not going to update my firmware. I'm going to try to do everything to not be stuck to it. So I'm looking for the lamp model, but why do I need to look up here? I already have the file. Give me a second. So 3D printing tools, right? It's not here. Yeah, it's not here. What is it? Where is it? Okay, I think this is the one. Loading. Okay, so this is the 3map file, and the way I work at this is that I design a hole here. I design a hole over here so that this entire lamp can be suspended from the ceiling. And I have printed 3 of these in clear PETG. Yeah, in clear PETG, and of course with a hole on them for the luminaire to go through. The main part that we are missing and that we need to design ourselves is the mount for the entire system. So we can do it right now because it is not available anywhere. This is very specific use case for us. Now I can make this one out of other material. However, the design constraint is a little bit specific, you see. Okay. Yeah, so we have to design a mounting system so that 3 of these So three of these can be suspended from a ceiling at different height. So we use the move command, so it looks something like, what do you mean I can't move it? Let me move it. Okay, I can move down but not up for some reason. So let's do it that way. This one is super low. This one should be somewhat halfway, and this one should be at the top. So something like this, and there will be a plate up top to suspend these three things down. Of course, they can be a little bit more spaced out, but yeah, we do that part when we design these things. So that is the main of it. So let's get to work. So we're in part design. We'll create a sketch, XY plane. I have read somewhere about the process of the Japanese train conductor is that they always set out their attack or action when they perform it. So in that way they are aware of the steps they are doing, kind of like anime characters shouting out the attack. Okay, so how are we going to tackle this problem? I think I should illustrate it first, right? I think I can illustrate it faster in other software. Let's go for PowerPoint, just for the sake. Okay, so this is the view from the bottoms up. So this is the bottom view. Okay, this is our bottom view. This is the mount that has already been mounted on my ceiling with a very secure mount. No line. Okay, this gray, yeah, and there are two small tabs located at these point. I'm just gonna make it like this. Okay, and they are exactly as I have measured to be how many to be where is that, 1850 millimeter. Everything is going to be in millimeter, so I'm not gonna to address the unit here. Okay, now these things over here, they are kind of like a square, and inside that square there is a circle. There's a circle. Right. Give it an arrow so people know that it's the same thing. Okay. There's this circle, and this circle have a diameter of 10 millimeter. So the plan is to design a mount which can take advantage of these dimensions, because the steel plate is here to secure a fan, a ceiling fan, so it is very strong. The main point is to design around this part right here. So it is not just a designing session, it is also brainstorming session to be exact. So should we tackle this, huh? My first instinct was to create a triangle in which the 3 points will be the mounting point for the luminaire. So it should no fill, right? Should be no fill. Yeah, it should look something like this. I wanted it to look something like this. And of course we have to account for the layer line, so because the entire structure will be suspended, and it can get pretty dangerous if we didn't do it right. So the main point, the first idea was to print 3 separate sections and then mount the electrical and mount the wires hanging down from it. But triangles, huh? I can, like, triangles is fine, I guess, but I can also do a circle right here. No. Okay, let's assume that I did a circle. I would need to design something that a little bit bigger, because the mounting point will be a lot bigger than this. So a base circle plate. Hold on. Before doing anything, I think we should take some measurement on this. The outer diameter of the lamp is 110 millimeter. 110 millimeter. Okay. So let's take that into account. So let's create a different sketch. Okay. Maybe use this thing, and the distance between let's call it between here and here. Should give it a different color. Red should be good. White, more white. This would be more clear. So that would be 110 millimeter. Let's double check. Yep, about 110. Let's give it some wiggle room and make sure it's 150 millimeter, of course. Millimeter. Wait, is it that much? 100? Yeah. Is it, I think we can give it a bit closer, 120. But being 150 millimeters would be better, right? Because this is not only the clearance, but it is also about the beauty, the looks of it. So yeah, I think 150 would be a bit better. Maybe 200. So this is 100, right? So oh, we must measure from the center. Okay. So 150 would be that far. I think 150 would be good. Don't you think? So 150 millimeter on this edge. This edge right here. Gotta make it a bit smaller. Yeah. Okay, the red section would be 150. This is will be the center of our circle, and yep, we already know the dimension of this, but we should just note it down. That is 110 millimeter. Okay, 110 millimeter. Blah blah blah. Okay. Okay. A circle wouldn't need to be able to go through all those points. Okay. So look at this. So we will have something that roughly look like this. Yep, roughly look like this. So we have all the known dimensions that we want. Okay, I think this would be good, but how do we incorporate this design into the base plate? Okay, so it will be entirely a circle with some spacing. I think this should be clear. 360 divided by 3. So they are 120 degree out of phase. Out of phase. Okay, 130 degrees out of phase, and yeah, this thing would be imaginary, so it should not exist like this. Yeah, imaginary lines. Okay. Wait, is it a bit too much? 150 millimeter. I think my intention would be 150 millimeter from the outer center or from the outer edge, because 150 millimeter from the outer edge would be a different matter. I think my intention would be 150 millimeter from the edge. Yeah, from one edge to another edge. That should be good. So the graph would look something more like stupid snapping feature. Can I just do make it longer and then move it in? Yep, good enough. So that would be 150 millimeter, much different than the other thing, and that makes the distance from here to here, make it red. Oh, I should make it different color, right? Green. Okay, wait, 6. So 150 plus the radius, this would be 55. Okay, so but they are both radius, so this one would be 260 because it is 150 plus the 2 radius, so we have 110 the diameter, so 150 plus 110, 110 would be 260 millimeter. Okay, we got our number, we got the specs. Okay, we know what we want. Now we need to brainstorm the design. How are we going to do it? I was first thinking about using a metal rod, and find a way to incorporate my design to it, but it's a bit of a challenge to be honest. Maybe I can design it into different parts because this is only 1000, so to put it in perspective, how do we find the diameter of this? What is the diameter of this thing? Doesn't matter. I think the tool can do this for us, but I think it will be much bigger. I think it will be bigger than this. So how do we design around this? Glue wouldn't be an option at all, and it is practically impossible to remove the gray base plate because some, let's just say, broken screws. Gosh, it's really hard. Is it worth it to design around the gray plate? I don't think so. Should I just try to remove the gray plate? You know what? I think we shouldn't keep the gray plate over here. It's not worth it. Makes the process much more complicated. Yeah, okay. I'm gonna stop the recording a little bit and try to see if I can remove it. Stay tuned. I'm gonna be back soon. Stupid me, I forgot to turn on the mic. Yeah, we make this 2-point symmetry around the y-axis. Yes, perfect. Now everything is fully constrained. I think I should practice the setting variable. Yeah, I think I should do that. Now I should bring it to your monitor, right? You are learning with me, so you should Google it together. How to set variable in. So it will be much easier to do it later. Okay.
Hi friends, welcome to my channel focusing FreeCAD. Today I want to work. For that purpose, the technical drawing needs to be processed. First, processing. While we are on this window, let's make it half transparent. We want to leave the image on XY plane and hit OK. Now we want to move the image to a suitable. We see the center of the station. False. That XY plane. We see that our object is symmetric by the horizontal axis, so we will only build half of the object and then later mirror it over on the other side. I will use polyline to draw the boundary to begin with. Polyline. In this sketch, we will address these gaps later from the previous sketch because the previous sketch in the tree and click this FX symbol next to a constraint. It indicates that the constraint has an expression or formula in there. This 40 will not be valid on the sketch, so let's go ahead and delete that. We want to move this edge inside, and this perpendicular distance between the two inclined edges will be 10 mm. External reference tool, and hit the edges. Another way to update a link constraint is to clear the formula from there. Notice that we cannot change this 25 to 35 because it is coming from an expression. So we want to clear the expression and then provide our new value as desired.
Where is that pointy bracket, baby? Should I just close it first? Yeah, this one. So give it a name, right? So, mounting holes diameter. Okay. Group is supposed to be. I don't understand what is base mean. What the heck is base? Type property length. Yeah, maybe that value will be 5 millimeter. And what is the tooltip? Intended property only alpha numerical. First capital digit. Application case. Each will start with a capital letter. No space. Oh. Okay. No space or underscore. Okay. FreeCAD with upper name case convention. First property name will start with a capital letter, no space, no underscore. Okay. Enter a group. Type. Optional. Tooltip is optional. Okay, so let's not do that. That's okay. All right. So how does that help us? So let's say we double click this reference. How do I do that? I remember have to press that button, right? And something like bar set, mounting hole diameter should be okay, right? Yeah, it's off. Why is it orange? Okay. Okay. Let's make this thing 6 millimeter. So it's now not the same, right? And now we'll change the diameter. Okay. Let's do raw set, mounting hole diameter, and we will use this. Seems to be working. Tap. Okay. Tap, tap, tap. Okay. Is it, why is it orange? Does it make any sense? Why is this thing orange? Why does it count this thing as over constraint? Maybe it's this one. No. Raw set, mounting hole diameter. Let's do it for all of our parameter right here. Raw set. Hmm? Close sketch. What is the warning? Unable to set geometry. So what if I change the value of this variable right here to 10 millimeter? Why is it orange? Orange is bad. Orange show that we are over constrained. These are redundant constraint, right? Let me check a little bit. I remember doing it before, but FreeCAD was set.
This icon here will create the object called the variable set. Let's do that. And it will create this object independent of the bodies. Let's rename the group. You can call it box. Let's start with line. And it will ask us for a new variable and width. Now we are prepared to create our first sketch. So we need the height, thickness, and it will be 3 millimeters. Let's close the report view, intersection, make our thickness, varset dot thickness, and let's divide it by 2. So what this will allow us is to change the thickness, and we will be confident that the lip offset will always be the half of the thickness of our box. So let's go and check our variables. You will see that it's now blue. It means that some calculations are going on there, and it's 1.5 millimeters. So let's dimension our first varset dot lip offset. And this is how we can dimension the offset for our geometry. However, the good practice, and you will see it if we delete this dimension, when we click the dimension tool and select our first point, it will try to dimension from the origin. It does that because the origin is always static in space and it is reliable. So no matter what, it will always be 26.7 millimeters.
Orange is normal. Good to know that. Okay, so we go back to borrow set this thing as 6. Yep, I think this works flawlessly. Let's keep it to 5 at the moment. Close the sketch. Think we have something good right here, and we're going to let's name it. Mounting plate. Okay, this is will be the mounting plate that everything will be mounted to. It has to be printed completely flat on the bed, but how are we going to connect everything to it? Okay, good question. Maybe we'll stick back to this idea. So we already have our mounting system, which is this. Now we need to spread it apart according to these dimensions. So how do we figure out? No, my goodness, this is geometry classes. My stupidity is showing. But I actually do love solving puzzle. So let's do it. Let's do this. So every single side will be 260 millimeter. And how do we find the radius of this thing? So if I remember correctly, if we can this line will be intersected at the point, and the point should be the radius. Oh crap, press in, zoom. So I select this point and pluck it around. So no matter where we move, it looks the same to me. Yeah, makes sense. I remember learning this at school before. Okay. And this would be 90 degree. So let's stupid PowerPoint. Okay. Shape outline, no shape fill. The outline will be no. It doesn't need to be dash. So we move it in, rotate it, and just make sure it's yep. It's 90 degree. It's 90 degree. And it's 90 degree over here. Perfect. So we do know these are 90 degree and they intersect here. Okay. Now we got something to work with. God damn it. So we extend this line. We have to extend that line over this. I want to do it the puzzle way, so like we can find this thing which is easy to find using Pythagorean theorem. So this thing um, the section will be 130. Yeah, the section will be 130. And using Pythagorean theorem, so we want the square root of this thing, right? So can we type it in? Square root square. I have no idea how to use this thing. $16,000. What the hell? $130. Wait, what? No. Two minus square. Yeah. 16,900. Okay. So we take this thing and what the hell? What the hell? Does it make sense? How is this equal to this? Doesn't make any sense. I must have been wrong somewhere. I think this is silly. Okay, much more sensible number here. And of course we can test that again. So we can take this number squared up plus this number squared up. Seems to be the same, right? What the fuck? 67,000, right? 67,000. 67,000. 67,000. About the same number. We're not perfect, so we're gonna take it, round it up a bit. Okay. So the section up to this point is this number. I think I would like a mathematical expression of this. So 62. There are no superscript here, right? Shit. So I'm gonna have to do it myself. Okay. So this line right here. Let's give it a nice color. Some blue. Yeah, it's blue, right? Some blue color. Boom. Okay, got it. Blue color. Now we need to add this thing. Now, because this thing is another triangle, we just connect these two dots. I think there's some math major over there is gonna go fucking ape shit over what I'm doing. But I think it works. Okay, so we have this is also 130 over here. We don't have this, right? Oh, yeah, sorry, my neighbor is celebrating that or something like that. Enjoy the music, by the way. Wait, maybe we don't need to know this section. We should need to know distance from here to here. Hmm. I think we can do that, right? Yeah, we totally can do that. Change of approach. Delete this noise. So we already know the half of this side is 130. 260 is one whole thing. So this side is 130. And we can find it. Let's go to the calculator. This thing minus this thing should be able to this thing, which is equal to this thing, and we can minus it again. Nice. Okay, I think we can get it. Let's give it another color so we can stupid snapping feature. Yep, from there to there. Yeah, good enough. Oh, why can't you just do what I told you? Give it a purple color. Bit more weight. It's so skinny. This thing and this thing is the same length. Okay. So we need to find the purple number. So we have this length already. I'm gonna need to make some marking. It's getting hard to keep track of. It was so much easier back when I was in school, but I guess I lost the edge up there. That's not good either. Uh, okay, how are we going to solve it? I'm getting stuck right here. We need to solve for a small triangle. Right? The direction we are going is to go for the small triangle and find out the distance from this point to this point. Let's use this thing to visualize a bit better. Let's give it a equation. So we will name it x. Fuck. Give a name. So x will equal to the blue part yeah, the entire blue part minus the minus this section right here. So radius. No, now we have too much variable. What the? Okay. Okay, give me a second. I'm a little bit slow. Sorry. Let's Google it. any formula for it, right? Are there any formula? Altitude, right? This involves knowing the area. Theorem formula. Property of unilateral triangle. Equilateral. Yes, all three sides are equal. Oh, okay. So this angle right here is have to be 30 degree. Make sense? There must be some proportion that we can use, like this one is 1/3 of this thing. I just need to prove it. Yes, area, perimeter, centroid. Okay, central unilateral triangle lies at the center of the triangle. Okay, to know the sides of equal length, we need to find the centroid. To find the centroid, draw perpendicular from each vertex. Circumcenter. Circumcenter is unilateral triangle is a position perpendicular by vector of the side. Okay. Equilateral. Yeah. Oh, oh, oh. Perfect. We got it right here. Radius of the make sure that if I don't circumscribe circle. Yeah, I thought it was circumcised circle. Geometry, set a point. So set a point. Each of them. Polygon. Okay, makes sense. Makes sense. So a over square root of 3. There. Much easier than trying to prove it. Sorry for wasting the time. So we got the radius, which is equal to square root of 3. So a over the square root of 3, and in our case a is 260 divided by, I think this is some stupid number. Let's um no, it doesn't make sense. Oh, it must be the inside internal circle. Fucking hate this calculator. God damn it. But I got no choice with it. Why can't it just let me use normal? I really wish I have the normal calculator. What the? Okay. Divided by S R T. What the fuck is? Oh. Like, does it have some sort of scientific, right? Doesn't make sense at all. What is going on? External. Learning math or what is the square root of 3? Oh, okay, I forgot to press enter. This fucking number. Wait, so technically, is it down? 150. Okay, doesn't make any sense. What's wrong with my number? Is the 150 red line wrong? Only one way to find out. 110, yeah? What is wrong? That thing is 260. There's no way this thing 150, right? I think I made some mistake in my measurement. Let's see. So the main idea is to have those points 150 millimeters apart from side to side. Okay, a reasonable number. And 150 plus the two radius should be a whole another diameter, right? So what is wrong with my estimation? 150 plus 110. I'm fucking losing my mind right now. Maybe my problem is trying to assign him. I've assigned him wrong. Something doesn't add up. The math isn't mathing. But if that is the case, I will have to comply. Okay. Let's design it. I think we can do it. It seems add up. It's hard to accept, but let's design it. Oh, I can rotate my mic like this. Oh, okay, okay. Without snagging on the table. Nice, nice. So you can now still hear me well. Nice. I didn't have to put the mic right in front of my face again, and I can still see my main monitor. The side monitor is a bit obscure, but that is its job, right? To work on side tasks like OBS right at the moment. Now we got the base. Now we need to develop an attachment system for it. Let's see what we can do about this. I forgot to add the middle hole. Let's give it a small number, 10 millimeter. just need to fit two electrical wire, so no need to make it big. So the center of these two lamps can be 150 millimeter apart without touching, of course. So we can change a little bit. Need some kind of this thing is originally 250. Oh my god, it's more complicated than I expected. Let me try again. How do we mount this baby? Should make this thing something more like 300 millimeter to match this thing. I can put it there with it. paper is so noisy. Gonna have to endure it. So we got this. Now we need I think we have to make it a bit larger. Yeah. So the mounting point doesn't overlap with this. Now we're gonna do 1, 2, and 3 mounting point on this thing, and they should be 100 and 260 millimeter apart. Okay, let's stick to the drawing. How do we mount it? Because the important question isn't if we can mount it or not, is about how secure we can mount it. So that's a challenge for us. We can give it hit threaded insert perhaps. We can give it a nut and bolts on the other side. So imagine this is the ceiling, right? So it will go through the hole and have a nut securing it, with the underside be a hook. That would be one way to look at it. Okay. How we design a secure mechanism for this thing? Maybe another thing. Maybe another mounting system. We just create 3 holes for this and use the hook design. The electrical wire will come through here from the ceiling, push it out, and be handled by other things. Let's make it a bit more easy to visualize. Pad it. Let's give it 1 centimeter, 10 millimeter of weight. Okay, this is the top, this is the bottom. So this face will touch the ceiling, and maybe not touch the ceiling, perhaps. Give it a little bit more space. Yes, we're onto something. So we can give it a little bit more space using some spacer, some kind of nut that can have a spacer in between. Yeah, some kind of spacer would be better because we cannot use a nut. We have to thread it into the ceiling. Okay, some spacers so over here, and but let's see. Okay, we're onto something. We give it some space. Yeah, some space is always good. We do all the electrical wiring stuff up here, and only the wires come down over here. Oh my goodness. Yeah, because at the end of the day, the wire will be suspending from this point. The lamp is very light, so I don't think it will be a problem. Okay. Let's make it true. This is the top. This is the part that we'll be touching, and we will now create a unilateral triangle with the constraint we had before. So it should be tangent to the circle, and this point is also tangent to the circle. We give it a parameter of 260 millimeter. So now this can be, yep, exactly what we want. And we give another side let's give it a name, a proper name. So I can double click, use this. No, okay, we can cancel this. Close the sketch, go into var set, and add another variable. So we call it I need to learn how to spell this thing. Equi. How do they say it in Oxford? Oxford Dictionary. This one.
Equilateral triangle.
Equilateral. What does the lateral mean?
Equilateral triangle.
So equal. Yeah, it's like equal, and lateral is like the side. Equal lateral triangle. So give it a name. Equilateral triangle side. Group base. Yep, length. The value would be 260 millimeter. Boom, boom, baby. Let's go. So instead of being with 260, it would be var set equilateral triangle side. Okay, same as this one. Var set triangle side. Okay, it's not clean at all, but it's what we have. Okay, now we can move them around. They can exchange. They have to stick to the circle, and final point. I think we will have to adjust the diameter of this circle to it's previously 350, right? Oh shit, I think I have made a boo-boo. Yeah, let's make this thing a construction line. So 310 first. Okay, this line, and draw a line first. This point, and the dimension would be it should be the same as the other. Of course, I think it would be invalid. It cannot be 260 because what is the one? And there was a set here. Yeah, it doesn't make sense. The computer doesn't like it because it doesn't make sense. I can move it around. Okay, I cannot move it around. So let's delete the constraint first. It would look something like this, right? This would be, how do we define the diameter of this? Or better yet, we delete this thing, right? We create the triangle. Yeah, it will be easier this way. Set triangle side. Perfect. Enter. Okay, now they are free to move because they are not constrained to anything. These points, however, are fully constrained. Not this point. Not this point. What the hell? I thought you were constrained already. Let's do it again. Center 10 millimeter. What the? Oh. Okay, why is it Why can't I set? What is the constraint here? Tangent to what? What? Can we check the tangent? Okay. Constraint 18. Can it be? I don't understand what constraint 18 do. What happens if we delete both of these constraints? These things still cannot move. Okay, makes sense. Cannot move at all. Now we have a unilateral triangle. Do they have a triangle too? No, I guess not. Okay, we now have this, and let's make this line and the y-axis, this point and the y-axis tangent. Oh, what the heck? Okay, coincide. Yeah, coincide is a lot better. Okay. Got our side, and we need to this is the construction line very soon. We need to create a circle. Yeah, a circle from the center, and I want to make a center first for the fuck. Okay, that's not what that's definitely not what I asked for. Circle, click the center, 10 millimeter. Now we're talking. Can it move? I don't think it can. Now we create another circle. I think it is setting constraint. What the hell? Oh, okay, I forgot about that. Shit. See, it's not that kind of center. And the distance is a difficult thing to constrain it like that. I think we need to constrain it geometrically first. Gonna toggle construction geometry for it. Wait. Yep, construction. These are simply construction. Okay. How do we continue with this? I don't think we need to, right? So we'll set a n. The n button, yes, should be 90 degrees. So to move up and down, but not swinging like a down. Okay. And we have to create some more lines. So 2 more lines to exact. This should be crap, there are so many options. Give me a second. Yeah, so we can draw the center like that. Yep, symmetry both point, and so does this. This will be the center. So we give it a line, a point. Oh crap! No, not that one. We give it a point. That is just, yes, tangent first, and we set the constraint this to coincide. Okay, they must coincide all the time. Yeah, the point cannot move anywhere. Perfect. Construction geometry. I really like that. GN. Nice. Okay. Now we can create our circle, and it's wunderbar. It's perfect. We can make something larger. 550, 500. No, 500 is a bit too big. 50 millimeter is too small. What the hell? How big should we set it? 300, 350. 400 is a bad number, so 500. So 50 centimeter. I don't think my printer can go that big. That's the problem, right? Because last time I checked, bamboo A1 that size 256 by 256. Okay, that will be a challenge because the biggest we can print. Okay. 256 by 256. So 256 is the diameter. So it is only that big. But what we want is much bigger than this. Okay. How can we print a bigger plate than what we have? I want to because splitting the plate isn't a good idea. It will affect the structural integrity. Okay, let's try another thing. So we will max out our parameter over here, and then we'll try to create another triangle. GN, create another line, intersect here, GN, and we said that this line and this line have to be equal. Okay, so no matter what I do, no matter how I move them, they have to be equal. And there will be a third one. To be GN. Okay, the third one can move, but we will not constrain it, so they also have to be equal to each other. Perfect. This fully constrained. I think I made a boo-boo. I can cut a groove into it. So we can print a groove over here so that we will lock into the channel using the groove. Okay, and that's one thing you need to consider. although it is much smaller. um, let's check the distance of this line. 221. Is it a bit too small between the two center? 221 between the two center. I don't think it will be too small. Not as big as I my liking, but not too small either. So I'm really proud of learning this. Really, that sketch is fully constrained, and we'll cut the semicircle into this thing. We'll cut a groove, and we will do that right now. So give it what is the diameter of my wires? Let me check. Wires right. Okay. The diameter of the wire is. Let's check with my dial calculator first. It is 3.30 millimeter. So we have 3.30. What about our digital calculator? 3 point. Yep, about the same number. I don't want to make it too tight, so it can damage the wire. 3. Maybe 3.5 will be a better clearance, I think. Yeah, 3.5 millimeter as the diameter will be better. Give it a bit more clearance. Definitely not 5 millimeter. Would be too big. Yeah, 5 millimeter would be too big. My radius is a positive number. 3.5 millimeter is not a positive. What the? How? Radius should be positive. It is a positive number. What the heck? Should I just do this? What is this bug again? So buggy tool line free. Not able to draw circle yet. Can make circle center point appear? Yeah, circle. Invalid from dark left solver. Let's see what our problem is. same as the Linux community, not helping much. Let's try with another shape. Oh, okay. These things are not overlapping as I'm seeing. This seems to be overlapping, right? So this and this. Okay. I think I'm getting somewhere. It is fully constrained, but when I zoom in, it is not. What's going on? Yeah, it's totally not. What is this? Delete. What is this thing? Tangent to where? Oh, I hate this icon so much. Delete. Why there's so many constraints for this thing? Okay. What is going on? Equals 17. Oh, it's constraint 17. Okay. I can understand the constraint, but why do this to me? I want this and this to be coincide. Okay. They now coincide. Perfect. And can I make this and this coincide? Apparently not. Let's move back. So something must be wrong with the diameter. Yep, diameter is fixed. It's true, 256, but it is not. How does this works? Okay. Let's draw this thing again. So confused right now. What the fuck? No. What is this point right here? Why there's so many of it? God damn. Okay. Take it from the top. Equal. Right? We got what we want. Okay, that's good. Intersect. Okay. These two should be. What is shortcut first? Equal is E. Oh, right. It is now working. I don't know about the number. The number would be some stupid number, but okay. Now I just just need this and this to be coincide. Good, that's good. Okay, now just need these lines to be G and okay, that is what we want. Now I think the problem last time is the circle not appearing. 3.5 millimeter. Yeah, yes, it is not appearing. What is wrong with this? Can I make it big? I can make it big. So when I zoom in, it's not perfect anymore. But when it's still in this, it is not perfect even in this form. What is wrong with this? Delete the constraint. I don't understand about tangent now. When I zoom in, it's not tangent anymore. Okay, we need to check again. Okay, it said it is tangent. Let's see if that's correct. I don't think it is. What the fuck is wrong with this stupid shit? Let's see what the internet said. Sketch your value, sketch first button. So let's close and try to validate our sketch again. We compute the object and let's try it again. Tangent. Okay. Alright. So right click. So in Sketcher, in task, constraint. I have auto remove even. I think this is an issue. buggy open source shit. Let's try another approach. This is the reason why FreeCAD doesn't have a lot of user base. We just use the coincidence. It already break at this point. Gì bà? I'm going to have to eat a bit. I'm gonna pause it. Okay, I don't want it to be a tangent. I want this line to be just a coincidence. Can it do that? Just a coincidence. But no. This is a symbol for coincidence. Because it looks. What the fuck is wrong? I'm going to wait for a while. Let's returning to solve the problem of tangent, not tangenting. Makes no fucking sense. But you know what? I can live with that. Now let's see if I can make a 3.5 millimeter. Okay, it doesn't show up. Why? Now it works. Now it fucking works. And not really, but what the fuck is wrong with this tool? Give me a second. Nothing works. Ooh. FreeCAD, what is that? This thing is 10 years ago.
Hi viewers and welcome to the channel, and today we're looking at Sketcher and tangent constraints and what they are and what they can be used for. If you like this video, please hit like.com. So if we've got any animations or anything, we can actually attach that circle to that line and follow that line. Unfortunately, it doesn't work on something like a B-spline. On something like this, you can't actually attach the tangent constraint in parallel with each other. So I'm clicking these two lines and using the parallel constraint. That means when I turn these lines, they will go around that circle. And I'm going to make these equal to each other as well. So we've got a quality constraint there. So they're the same size. Is kept with those lines. And you can see that arc's changing as we're
Okay, let's do some reading to see if we can investigate. There was from the draw proper close-up sketch itself. So how about we use this thing doesn't work. Let's just do it anyway. Yeah, let's just do it anyway. So we'll create that triangle once more. These two will be equal, and 2, 3 also equal. Now why is it secure? Does it make sense to be secure at all? Now why is it snapping? I don't remember adding any other constraint, right? I have a feeling that my circle isn't circling if that makes any sense. So it's not a perfect circle anymore, except this point is always not always. So how do we know for sure if remove another constraint? Okay, there is only constraint for these two lines. Let's check and for any irregular constraint. Yeah, what prevents me from going up? I wonder. So this looks very similar to my case, which they have a tangent, but it isn't tangenting. No connection at all. Yeah, it's more like a band-aid. most of these Linux open source stuff, they don't care about getting the things done right. Logan default mode for switching. In the sketch, this cursing constraint applied to this one. Instead is the display issue that shows semi-disconnected arc when zooming in almost less than. Okay. So what is the validate sketch button? Tool is in part design. So close this first. Tool is in part design. Why is this 3-point locked? If it is any other circle, it would have moved, but right now it's locked in place. I can work with this, but it's not reasonable. Okay. Where is this button? You can see view sketch. Where is the button?
Hi, this is CAD-CAM Lessons channel, and in this video I'll show you how to create 3D. So let's edit this sketch, and this is paint. It may be that, okay, but not connected. This is visible here. We have degrees of freedom and information that geometries are not constrained, but when creating geometries where dimensions are not crucial, we might overlook this, and even if the sketch seems correct, we won't be able to add a solid based on it. And while it's easy to locate issues in simple sketches, it can be more challenging in complex geometries. But for the problematic sketch, go to the Sketch menu and select Validate Sketch. Here, click this button and FreeCAD highlights the vertices with issues. Close this tool, go to the sketch editing and verify these vertices. Okay, select.
Okay. Close pad operation. Okay. It's freaking microscopic. Let's go to the sketch. Yes. I'm not good with computer, but why do they have to change the name of the element? Why can't I just add another new one? Yep, they are referencing the wrong edge. I get that. They are rebuilt and renamed. That's the problem. Oh my god. So why is my triangle not working? No fucking clue. One of them works. One of them works. I'm gonna be fucking sick doing this all day. This works better, much better. Why doesn't work the first time around? This should be what happened. Alright. Now I'm gonna make this and this also be coincident. Now the sketch is fully constrained. I select these three, make it that, and now is the crucial part. Trying to, yep, it's still not the same thing. I'm gonna have to live with that, I guess. I'm gonna zoom in as much as I can. No fucking clue. 3 million, 0.5 millimeter. I'm going to have to deal with that, but okay. Can I trim it? Trim. Zip the tool. Okay, before we do anything stupid, let's try to save sketch first. So FreeCAD, ceiling lamp. It's gonna be a pain. It's gonna be a pain in the butt. What if I delete? hard, but can I just update it? Yeah, they are not coincident, and when you zoom it close enough, it becomes a problem. Oh, I have deleted Reddit, so can't use this. According to the big man, he's saying coincident, so we have to take it at that. 3.5 millimeter. So it's this one. Now we have to trim it using the trim. If this thing gives me error such as not constrained, open wire, I'm gonna fucking lose my shit. Okay, still works for some reason. It have updated. Okay, still not center, but I don't understand why this limitation exists. I guess that we have to do. Okay, looking fine, looking fine. Oh shit. Okay. So failed to converge on what? Can you? Cut the groove already, but why is it not working? What is the error message? Maybe it's the point right here. I should make it every time I press delete, a new thing fail. What the fuck? Infinite glitch or something like that. I'm gonna try the Verde sketch. This thing is fucking worthless. Oh. Edit preference sketcher. Okay, let's try that. Edit preference. Oh, sketcher. Okay, display. What's next? Segment per geometry. Okay, segment. Apply. Let's check my task manager to see how it goes. Still alive, I guess. Holy fuck. Wait, is video encode from OBS Studio? Yeah, we're recording 4K, so it's bound to consume a lot. Overall, nothing wrong. But still didn't answer. Okay, another question. Yeah. Why don't they let us do that? What kind of bullshit is this? So let's count the circle. 1, 2, 3, 4, 5 something circle. Arc. Okay, it's highlighting for us. Two, three. Where is that one? Okay. Let's come back to the point before we delete. We trim this edge. Constraint 17. Okay, let's delete that. Let's see what's happening. This one is failure. I don't. Oh. You know what? This is why we have a duplicate version. Discard. Good thing we save it before we do anything. this is the part. I think this is the main reason I make these kind of videos, to show people that stuff is not easy. Doing something takes a lot of time, and because of software like this. Okay, it's a bit better, but let's try sketch. Edit, preference, sketcher, display. So how about we look for 1,000. Okay, it's a bit better now. 1,000 is decently good. GPU, CPU consumption is barely anything. 1,000 should be good. Yep, it's much better. Much better now. We are talking very small. We are zooming in infinitely. It's still pretty good. I can look at this, and yeah, it actually coincident already. So it is 100% display issue, not my problem. And now we try to trim the edges. Okay, let's try that. What the? No. Okay, fully constrained. Yep, good. Let's move it back in. Try to trim the edge. This one. It is now under constraint, right? How about we go back and yeah, the UI is much worse on a 2K screen. The text, like from my normal sitting distance, I can see the text on stuff like body being much worse already, and my eyesight is not particularly good either. So seems like you can see the difference in 2K and 4K. It's not game breaking or anything, but yeah, it does improve your experience a lot. I've been working for almost 3 hours. Oh. Okay, looking pretty good. I'm gonna have to chamfer it a bit so it doesn't rub the wire out. Other than that, it seems to be fine. So this is the top surface. Create some spacer, screw it in, wire all the stuff in here, the wire connection, the soldering, and then just hang it down. I think I'm gonna solder all of it. Should I solder all of it? I'm gonna solder it down here. And just connect the two big wire. I can just use the quick connector. Yeah, I think I'll use the quick connector for this. And yeah, that way we don't need spacer to be that big, that much bigger than needed. Let's check a bit more to see anything wrong. I think some glue, some kind of glue or tape will be used, but Two degree of freedom. Are there any 90-degree constraint? So what if we do this? Doesn't work. Okay, good to know. It can move because okay, let's try this. So we will define a distance between the 2 points. Yes, define it like this. And can it now? Doesn't help. Alright. Yeah, the little triangle, the big triangle can move a lot. Alright. So instead of that, can we just constrain the triangle in here? So from this point to this line there will be a dimension, and it can still move up and down. Alright, so this point and this line will be also have another dimension. It seems to be works. It works for me. I want to try this. The distance. So we'll constrain the distance to the center. How does it move? It can still move without affecting. Okay. I think we are set. Okay. Add some chamfer for the wire over here. I know will look pretty bad, but I think it's worth it to make sure the insulation is not damaged. Fit it? Is it fitted? Boom. Neat. Okay. Seems good to me. Okay, I didn't expect it to go that good. So what we learned today is to remember increase the resolution, because it barely consume anything. This is how much GPU the OBS consume. This is how much FreeCAD consume. 0. Yeah, very slow. So no need to fret about, oh, my PC can handle that, because look what I have here. You see this i5 9400F, not a good CPU, not top of the line or something like that, and it can handle much better, avoid all the headache. I believe that should be the default. And I think we got it. Okay, save it already. Perfect. Select the object, file, export the object, STL. Yeah, STL only. Save. Great. Right up at the edge of the printer. Couldn't be closer than this. So how long would it take to print it? On 0.4 millimeter standard. 4 hours only. Stepping is not too bad. I can live with this. Yeah, I think it is enough to prevent the wire from snagging. Goes fast. Oh, grid infill first. I think it would be should be 100% solid. I don't want this to fall on top of us when we eat 12 hours. How much? Holy shit. Okay. It's gonna took a lot of plastic. Can I make it thinner? Should I make it thinner? Oh, I think it should. It needs to be solid. Yeah. 1 centimeter of plate is a lot. Should I cut it in half? Now I know I'm thinking like an engineer, but yep, I'm gonna have to reconsider it. 12 hours to print. I can live with 12 hours, but holy crap! I know patchy is not that expensive, but 600 grams of plastic. We're gonna consider it later. It is good. No. Discard. I'm gonna measure for the spacing again. Okay. Thickness of this thing. This thing is not. This thing doesn't even sit flat. But I'm gonna try my best to measure it. It is 10, 14. It is 14.7. Let's give it 15 millimeter for a bit more clearance. Yep, 15 millimeter for a bit more clearance. Okay, we can close it now and create another sketch. In this sketch, we will only sketch the spacer. Oh, I forgot. Ooh, crap. I'm gonna have to make this thing a bit larger. So 10 millimeter. Yeah, 10 millimeter is good. So we go back to our sketch. See this hole over here? Click on it. Oh, we don't have to click on it. We just change the var set to mounting hole diameter 5 millimeter to. Let's go for. Let's go for 8 millimeter. 8 millimeter should be good. Boom, bigger holes already. Nice. I might want to design a bit deeper or a groove at an angle so that it doesn't slide out as easy. But this is much more simple, doesn't affect the structure integrity. Tough choice. Also, I think I should really cut this thing in half. So 7 is a lucky number, right? 7 millimeter, and save it. Okay, now we go to the sketcher. We create the spacer for it. We have agreed that the spacer for this is 15 millimeter for the purpose of clearance. So we create new. This should be easy. Displaying. Now, because the hole is 8 millimeter, we should create something at so the inner, we first have to think about the inner diameter, right? So it should be 8.5 millimeter. That's the inner diameter, and the outer diameter should be 10. So is 10 a bit too small for it? Maybe 12. Yeah, 12 is good. 12 is good. Boom. There we go. Spacer thickness. Boom. Okay, we got it. Mounting spacer. Damn, I'm on fire. So I think we got it. Okay, I think we got it. Good job. And this is it. After 3 hours, we have managed to design something that is functional. So stay tuned for the update. Thank you. What is my motto again? The journey of 1,000 miles begin with a single step. So stay tuned for my next step. Goodbye. See you again.